Next up, we got the combined gas law. This law looks like this, where you are comparing pressure, volume, and temperature of your initial numbers and your final numbers. You know that you have to use this equation when you are given all of this information of pressure, volume, and temperature, and none of them are constant. So all of them change, and you usually have to solve for just one. So let's start by writing our equation. P1 V1 over T1 is equal to P2 V2 over T2. And now we have to find our variables. So I'm going to have pressure, I'm going to have volume, and I'm going to have temperature of initial values. And then I'm also going to have pressure, volume, and temperature of final values. That's why they have a little number 2. Let's read the problem. A 324 milliliter sample of nitrogen gas is at this pressure, ATM, and this temperature. So this sounds like initial values. So I'm going to write them right here for my initial values of variables. So my volume is 324 milliliters. My gas is at 3.04 atmospheres. So that's pressure. Atmospheres is always pressure. And temperature is 300 Kelvin. For these problems, a really important thing to make sure of is that whatever units you are using on your initial data, you will have to use the same units on your final data. So for this exam, you don't really have to worry about conversions, but just be aware that that is something that can get tricky in an advanced chemistry class or in a longer chemistry class than what we've had. Okay. The sample is changed to have a volume of 103 milliliters. So this is the new volume. See that the units match, milliliters, milliliters. The new temperature is 420 K, so 420 Kelvin. I am working with Kelvin and my units match. Again, temperature always has to be in Kelvin for all of these problems. What is the new pressure? So I am solving for P2. So I have to plug these numbers into my equation. So P1 is 3.04 times V1, which is 324, all over T1, which is 300, equal to P2. We don't know, so I'll leave it as P2. V2 is 103, and T2 is 420 Kelvin. All right, so now I think this is the hard part of these problems, where you have to cross multiply to find your answer. So I'm going to cross multiply, make a pretty little butterfly, these ones. So 300 times 103 times P2 is equal to, cross multiply this side, 420 times 3.04 times 324. All right. All that you're doing is cross multiplying, setting both sides equal to each other. And now you can just solve the math. So let's do this side. 300 times 103 is 30,900 times P2, which is what we're solving for, is equal to 420 times 3.04 times 324. That's a big number. So let's see, 413,683.2. Okay, so now to get P2 by itself, we need to divide both sides by 3,900. Divided by 3,900. Divided by 3,900. Oh, too many zeros. 3,900. And that is approximately 13.39. So P2 is equal to 13.39. Because P2 is a pressure and our pressure is an atmosphere, our final answer is 13.39 atmospheres. Remember, units are very, very important for this unit. Haha. All right, next one. Same steps. We need to find our equation. P1 V1 is over T1 is equal to P2 V2 over T2. I know that for these problems, I am only going straight into writing the formula without reading the problem. That is because I specifically made these like combined gas laws. When you are taking the exam or when you're reading any kind of problem, just look at what variables they give you. This one gives you pressure, it gives you volume, and it gives you temperature. Pressure, volume, temperature. That's how you know. Okay, so let's find our variables. We're going to need to find P1, V1, and T1. And we're going to need to find P2, V2, and T2. Okay, calculate the final pressure. Boom. Immediately I know that I need to find the final pressure. So I need to find P2. Of a flask, if the original pressure was 3.7 atmospheres, 3.7 atmospheres, and the volume increased from 60 milliliters, so I had 60 milliliters in the beginning, to 130 milliliters, and I have 130 milliliters at the end. And the temperature decreased from 285 Kelvin to negative 48 degrees Celsius. Do you see these units do not match? I have to change my temperatures all to Kelvin, so I'm going to have to fix that little thing. So I do that by degrees Celsius plus 273 is equal to Kelvin. Negative 48 is my degrees Celsius plus 273 is equal to, so that's the same thing as saying 273 minus 48, 225. 225. So 225 Kelvin. And now look, all of my units match. My temperature is in Kelvin and it's on both sides. I have milliliters on both sides and I am solving for pressure. Okay, so now I can plug these numbers into my main equation. P1 is 3.7 times V1, which is 60, all over T1, which is 285, equal to P2, I have no idea what that is, I am solving for it, times V2, which is 130, all over T2, which is 225. And now I'm at the step where I need to cross multiply. So I'm going to cross multiply this. 285 times 130 times P2 is equal to, cross multiply this, 3.7 times 60 times 225. And now I am just doing the math. So 285 times 130 is equal to 37,050. 37,050 P2 equal to 3.7 times 60 times 225. 49,950. 49,950. And I want to get P2 by itself, so that means I have to divide both sides by 37,050. So divided by 37,050. 1.35 approximately. P2 is equal to 1.35 approximately. Because we're dealing with P2 is pressure, and my units are in atmospheres, my final answer will be 1.35 atmospheres, ATM.